Welcome to the Bootloader. I'm Paul Cutler.
And I'm Todd Kurt. We have a special episode for you today with an interview with Justin Myers, the author of the CircuitPython library ConnectionManager. Before we get to that, though, Paul and I each have a couple of things to share with you, each not more than a few minutes long. What's your first one, Paul?
My first one is how to level up at CircuitPython. Professor John Gallaugher of Boston College recently released two videos I wanted to share. One for how to migrate from using Moo in CircuitPython to using PyCharm with TIO, and a video on using CircUp to install and update CircuitPython libraries. If you're not familiar with Professor Gallaugher, I talked to him way back in episode 3 of the CircuitPython show, which I'll link to in the show notes. He teaches a class called Introduction to Physical Computing, which uses CircuitPython along with microcontrollers to teach students computing concepts. He has other YouTube playlists worth checking out on his YouTube channel, especially if you're newer to CircuitPython. I'll link to those as well. But back to his new videos. The first one is how to correctly set up PyCharm on Mac OS to use with CircuitPython. Most of this is applicable to Linux too, and I learned a few new things. It's a longer video at about half an hour, but the professor walks you through how to correctly configure PyCharm, and he's using the free community edition in the video. Next, he covers using the new and updated CircuitPython set board, so you have code completion for your microcontroller in PyCharm. That might be brand new to a lot of people and is definitely worth watching. From there, he covers using TIO, an open source serial program that is way better than using Screen. It's got auto reconnect as its killer feature, and I think it's pretty cool that he included TIO as the serial monitor in Moo is one of its key features. Next up is a 15-minute video on using CircUp to install CircuitPython libraries. If you've used CircuitPython, chances are you've downloaded the Adafruit library or the community library bundle, and then you have to find the right library out of hundreds. But what if you could easily use the command line? He walks you through how to use CircUp from the command line, and then for Mac OS users or for Linux users using the ZSH shell, he shows you how to add tab completion by updating your ZSH configuration file. CircUp has also been getting some love over the last few months. Shout out to Tim, aka Foamy Guy in the Adafruit community. He's been doing some refactoring and adding new features as well. I know I learned a few things, and if you use CircuitPython and you're looking to level up your CircuitPython workflow, I highly recommend checking out these videos from Professor Gallaugher.
I love CircUp. It's sort of like, if you've never heard of it, it's sort of like pip. The Python package manager, but for CircuitPython, and it hooks into the two big package repositories that exist for CircuitPython, the Adafruit one and the community one. It's so good, but it's a little bit hard to set up if you've never done any sort of Python setup before. So this video is like super handy because I get people asking me all the time, how do you install a CircuitPython library?
Right.
And like this, just like the answer is just use CircUp, but then the question becomes, well, how do you install CircUp?
And I think it's really cool that he actually walks you through on how to update your ZSH shell for the tab autocompletes, because there's hundreds of libraries, and it makes it just that much easier to find the library you're looking for.
I really want to follow his steps on how to set up that PyCharm IDE, because I don't really use IDEs in the normal sense. I just use a text editor with code syntax highlighting. But there's so many people that have been trying to use the VS Code CircuitPython extension, and it's been sort of perennially broken. So people are so frustrated using it, and it looks like PyCharm is really well done. And there's this nice now intro video on how to actually meld it with CircuitPython, which is a little weird because most of the times when you're editing Python with an IDE, you're editing the files sort of in a project, say, and when like CircuitPython is a little bit different in that like the code lives on a device and you edit the device, and so maybe your actual project is in a GitHub repo that lives on your computer somewhere. And so how do you deal with those two sort of separate views of your code? And I think PyCharm can help you with that.
It can, but you're still writing directly to the microcontroller in the way that it's set up in this example, because I know I use PyCharm and I did learn a couple of things, but there's still a lot of copy paste. Because I commit everything to my GitHub repo, so I'm writing locally, saving it there, and then copying it over to the drive, and as soon as I hit save, running the code. So
that's usually how I work as well. But I see all these people that try to use Moo because it's easy to use, but Moo's getting kind of crusty, and Thonny, I don't know, Thonny just always seems like it breaks my CircuitPython install whenever I try to use it.
Sure. Yeah, it's too bad that Moo's getting a little long in the tooth. It's an open source project. It needs a little love, but it's nice to see other alternatives out there that are well documented.
Yeah, no doubt. Yeah, I mean, the cool thing is that because it's all just a text file, you can use anything that can edit text files to edit your CircuitPython code. But it'd be nice to have a really good IDE for those people who need IDEs.
What's your first one?
All right, so kind of related, Professor Gallagher also does a lot of how to program iOS apps for Apple devices. And so those are written in Swift. Swift is a programming language that Apple has been developing for the last 10 years. They use it on all their platforms. It's the officially recommended way for writing apps for iPhones, iPads, Apple Watch, things like that. And Swift is a really interesting language. It's heavily influenced by Haskell and Rust. These sort of academic languages that emphasize type safety and functional programming, where the compiler itself can catch a lot of bugs as it compiles your code down, which is kind of foreign to how Python and JavaScript work, where you just kind of run your code and see if it crashes or not. And so there's this whole academic effort in computer science that like we should be able to make provably correct programs, or programs that we can prove will not crash for certain classes of crashes. That's what Haskell and Rust kind of comes from. That's where Swift came from as well. And it's a really interesting language. It looks a little bit like C, but with all these sort of extra neat things on top of it. It was created by Chris Latner, who developed LLVM and the Clang compiler, which you probably seen in various places when you've installed things. It's been the sort of revolution how to compile C-based or C-like languages. And so I think you'll see LLVM and Clang a lot more going forward. But Swift uses those two things underneath to do its magic as well. And the reason why I'm bringing all this up is because Apple just released something they call Embedded Swift, which is a version of Swift that runs on microcontrollers, which is like amazing. Like this is a super high level language, in many ways higher level than Python or JavaScript, and we can run it on a microcontroller on things that are even some ways smaller than what CircuitPython type controllers can do. And not only did they release Here's Embedded Swift, but they also released working demos for the Raspberry Pi Pico, the ESP32C6, the NRF52840, which is a BLE chip, and the STM32 chips. And they've also released a bunch of examples on how to participate in Matter, a Matter network, which is the new standard for home automation that Apple's HomeKit API does. And I think Google's Echo platform also does now. And so there's and it's all on GitHub. You can just go to their Swift Matter examples, see the smart light example that you can like run and control. You can make a controllable smart light with Siri in about 60 lines of Swift code. And it's all, it has a lot of the same features of real Swift, of like, the type safety, the functional programming, that kind of stuff. And it's just sort of amazing that like we're getting this super high level language running on tiny chips. And I've not looked at it too much yet, but in the show notes, there'll be some links to some other articles describing it and links to the GitHub that has some examples. So you can actually try some of this stuff out on your Pico or ESP32.
I only know Python, and this has me really intrigued, especially the Matter integration, right? We don't have that in CircuitPython yet. I don't think Arduino has Matter integration that I've seen. So actually being able to write my own smart home apps on microcontrollers would be a really cool use case, and actually has me thinking of learning a second language.
Yeah, it's like supposedly there's Matter APIs in the latest ESP IDF, the SDK that you use when you're writing C code for the ESP32 chips. And I think that's what these Swift Matter examples are using under the hood. But do you really want to be mucking around with C code when you could use a high
No.
level language like Swift? Yeah, yeah. And so it'd be nice if we get Matter support in CircuitPython someday. There's no reason why we can't.
And I think Jepler might actually be working on that really, really early stages.
Nice. Yeah. I would love to see that. All right, Paul, what's your number 2?
My number 2 is accessibility matters. When I first started contributing to open source about 20 years ago, one of the first projects I contributed to was the GNOME project, the Linux desktop environment. One of the core pieces of GNOME's culture is accessibility, which includes everything from the Orca screen reader to how we wrote documentation back then. The worst disability that I have personally is being extremely colorblind, but that focus on accessibility has always stuck with me, which is why I'm excited to see a project like this. The first is the access bit from Dr. John Vidler in the UK. The Microbit Educational Foundation commissioned a report on accessibility, which included a speculative section on how to improve the microbit platform for those with limited or different mobility. If you're not familiar with the microbit, it's a microcontroller primarily made for education, popular in the UK and Australia, that features 2 buttons, a 5x5 LED grid, and connections for alligator clips. It can run MicroPython, CircuitPython, and MakeCode. The report included a few sketches on possible solutions for potential 3.5 millimeter audio jacks, which are the industry de facto standard for accessibility, like what are found on Microsoft's Xbox Adaptive Controller. Dr. Vidler decided to design a PCB as a minimum viable product to add 5 adaptive switches. He walks through various iterations of his design, landing on a final design that includes an edge connector to connect to the microbit and room for 5 3.5 millimeter jacks. It's pretty cool the thought that he put into the design, from how the add-on board connects using the 40-pin microbit controller to the curved design of the board. He had JLC PCB make a handful of boards and sent them off, and they were shown at the Blockley Summit in Cambridge earlier in June. Check out the show notes to the link to his blog post detailing the process, including photos. The second product is a new Adafruit product, the TRRS Trinky. Adafruit's Trinky line includes a USB-A port to plug it into a host computer and a small board, maybe the size of a flash drive, so it's pretty small. The TRRS Trinky has a SAMD21 chip, has one 3.5 millimeter jack, and can run CircuitPython or Arduino. I think it's great that those who might need it have more options for accessibility, especially using microcontrollers, which they can program to their needs. I'm excited to see what people can think up using tech like this, especially if it makes their lives easier.
These are a great sort of combo, because the Adafruit TRRS Trinky is purely just a USB device. It's like looks like a little USB thumb drive almost, that just has a 3.5 millimeter jack on the back. But the microbit, it has Bluetooth. I mean, it does USB as well, but it has Bluetooth, and so you can now make a Bluetooth accessible controller with this little add-on board by just snicking the microbit into it and then plugging in some of these accessibility controllers into that, and then pairing it with your phone with a little bit of code with MakeCode or something. That's incredible. I think there'd be a lot of fun things being created with this.
I agree. What's your next one?
So my next one is about CadQuery. So I've been on a journey to move to open source tools for my engineering work. I've mentioned before, I've gone from using Eagle to KiCad. I use Fusion 360 for my 3D CAD modeling, and it's pretty good, but I'm always irritated after using it. So for a lot of different reasons, what are the open source alternatives? And like, if you're going for a GUI 3D experience, there's things like Blender. But I like parametric modeling. Like, one of the nice things that Fusion 360 does is you can make everything parametric, where you just define a set of constraints, and then you create solid bodies from those constraints. And Blender's not really that. Blender's more of like a artist's tool. It can do a little bit of it. So for the longest time, there's been this thing called OpenSCAD, which is a textual 3D parametric modeler, and it's a GUI app where you've got 2 panes. One pane is the text of the OpenSCAD language you write to create cubes and pyramids and cones and ways to combine them in different ways to make your 3D object. And then on the right is a render of what that thing looks like. And so from that, you can, and people have done this to great effect, make enclosures and other 3D things that can be 3D printed. Like, I think all of the Prusa components in the Prusa 3D printers are all actual SCAD models that somebody has designed as text files. And so you can, if you need to make the screw holes a little bigger because you're building it by hand and you're 3D printing the pieces and you only have M5 screws instead of M3 screws, you can maybe just go into the OpenSCAD file and change one little parameter and change all the screw hole sizes. But I've always bristled at OpenSCAD because it's got its own special language. And I've been looking at other things, and I just discovered recently the thing that's been around for a long time called CadQuery, which is like OpenSCAD, but it's all in Python. It uses standard Python syntax, and it is mostly a library that you can then express via various ways. You can just run a main.py and have that output a file, but you can also run this thing called CQ Editor, which is a GUI editor, kind of like the OpenSCAD editor, where you have multiple windows and you can edit text in one and see a render in the other window. And I've been using that, and it's kind of working. I don't know, even though I've been using CircuitPython for so many years, I'm still not a very good Python person. So this is like kind of diving into more Python. The reason why I discovered this is Luke Wren, who is one of the ASIC designers, at Raspberry Pi. He's one who's helped us do some of the clever PIO things that we've done with the Raspberry Pi RP2040 chip. like the cool synth.io and PWM and touch sensors and stuff is all kind of because and most especially the HDMI output from a little $4 microcontroller is because of some of his hints that he's given us. But he has a GitHub repo of a bunch of CadQuery files. So if you want to see how CadQuery things look, what the Python looks like, you can just go to his repository and go, oh, look, there's a little vacuum adapter, and here's an air duct plate or whatever. So there's a nice little library of things for you to kind of browse through and see what CadQuery feels like from a language point of view. But one of the best things about CadQuery is that unlike OpenSCAD and unlike the similar OpenJS CAD, which is the same thing as OpenSCAD in some ways, but with JavaScript, CadQuery outputs step files, which are object files, not STLs, which are like tessellated, triangulated shapes. And I was really frustrated that like OpenSCAD doesn't have a step export feature, because if you have a step file, you can now import that into another CAD program like Fusion 360 and then do additional edits on it. Whereas it's really hard to do edits on meshes. Like the STL format is made for output for 3D printing. It's like the bitmap version of your vector file. And so having a step is really important to me. And so I'm going to be playing with CadQuery over the next whatever months or so and see if I do anything with it.
I share your excitement for that. As I mentioned earlier, Python's the only language I know. So looking through some of those examples, it's started to click for me. I've tried to use OpenSCAD and never could figure it out. I can't use FreeCAD because they don't have a colorblind mode. And Fusion 360, I've never really gotten the hang of. I've had some luck with Onshape, but actually having the ability to actually program it and with the examples that they've got, looks really cool. Thanks, Todd. And now we have a special guest, Justin Myers. Back in episode 7 for the CircuitPython 9 release show we did, I mentioned ConnectionManager, but kind of guessed how it worked. Well, I reached out to the author of the new library, Justin Myers, and asked him about it. Here's the interview. Justin, welcome to the show.
Thanks, Paul. I'm excited to be here. To be honest, it's my first time I've been on a podcast, so I'm really excited about it.
It's great that you're here. What is the new CircuitPython library, ConnectionManager, and what was your inspiration in creating it?
Yeah, so basically, late 2023, I had decided to spend some of my, we'll just call it extra time, working on CircuitPython and trying to see how I could help project. I love the open source community. And as I was kind of watching the threads, I just saw kind of user after user on Discord having different connection issues, running out of sockets, different things like that, memories issues and everything. And I was like, seems strange, should be a better way. And so as I kind of started digging in, saw like each library kind of managed sockets differently. And if you really think about it and look at the differences between like a microcontroller and CPython running on a PC, is like on CPython, you can open sockets all day long. Nothing really happens. But then once you get to a microcontroller, it's different. And kind of once I started digging into that, I was like, oh, well, you've got the native Wi-Fi that does it one way. You've got like the ESP32 SPI that does it one way. You've got the WizNet 5K that does it a different way. And just kind of all this boilerplate and different ways to get the SSL connection and different things. And I was like, this is weird. Like there should be an easier way to do this. And so it's kind of what started me going down this road of trying to find out, like, is there a better way to do this?
And what was the better way?
So basically kind of the flow went, I asked the comment on the CircuitPython dev channel on Discord. I said, hey, I've got this idea. Basically, the requests library had this built-in session manager that kind of managed a bunch of the sockets. But oftentimes what users would do is they would just reinit that thing and lose all the sockets. And so they were still technically open, just sitting there. And so kind of that first pass was I basically kind of separated some of that out to a separate class and kind of shared that with the devs. And they were like, nope, let's create a new library. Like, that's not a good way to do it. Kind of break up dependencies and everything like that. And kind of from that, there's literally days spent kind of back and forth on like, what should we name this? And so ConnectionManager was kind of where that was born, and basically just started separating a bunch of the stuff out of what was in the request library and putting it into this new one and then building handlers that would take in whatever radio object you passed in and try to determine, oh, what's the right SSL method for this one, reducing imports from 5 or 6 all the way down to just the 1 or 2 that were needed.
And that's really the key, isn't it? If you have a Pico W, it was doing it different than an ESP32S3. And now for the user, that setup instantiation is almost the same across the different microcontrollers. Is that right?
Yeah, and that was kind of the goal, right? Because if you think through how CircuitPython started and once connection happened, right? So the ESP32 SPI was one of the first ones, right? Developers, wrote that library, and then they kind of mimicked it a little bit for the WISNet, 5K. And then when the new ones came out, like ESP32, S2 and S3 and things, and they started having this onboard Wi-Fi, they changed how they did it again, right? And with anything that's open source, they're running forward as fast as they can, and sometimes it's hard to go backwards to go update everything. There were depreciation flags and comments, not flags in the code. And so, and all these places we should get rid of this at some point, but it was still there, years or months later. And so a lot of it was trying to trim some of that down.
What was it like to partner with the core developers on ConnectionManager?
I really enjoyed it. It was really It's been a really interesting progress for me. So a lot of my development started in C, 20 plus years ago when I started doing dev. And a lot of it was for, smaller systems. And it was at a time where you had to do memory management and really think of your code for what's going to be the fastest and most efficient ways. And in the last 20 years, I've, switched over to things like Python and things where, and JavaScript and everything where a lot of that stuff's just handled for you and you forget about it. And so it's actually been really fun, because they'll make comments on PRs and oh yeah, that's a wasteful way to do something, right? Because there's not a lot of space, so it's, really small and trying to think through it, but they've been great. There's been times where a handful of them, we've jumped on calls together to kind of work through some things and figure it out. They've been great on the comments and asking questions and whatnot. And so I think the CircuitPython devs it's a great team to work with.
Well, that's great to hear. What's next for you in ConnectionManager?
Kind of where I've been going next, I've been opening a handful of PRs to make the radios, again, more similar. So, for example, they all had different ways to find out, what AP am I connected to? What's my MAC address? And different methods of returning everything. So I've been continuously working to try to get the different radios as close to the same as possible. And so really for an idea of a typical user probably goes out and they buy a microcontroller that's got whatever Wi-Fi it has on it, and they go run with that project and go. But oftentimes they see a lot of the questions are someone sees a Learn Guide and they're like, well, I don't have that stuff that's in the Learn Guide. I have this. But then they really struggle to try to figure out how to get it all to work because these different methods are different. So it's really been working to get all those core methods the same. So you can, for the most part, copy paste other than initializing the radio itself. And the work I'm doing currently now is I'm actually building out some network test code that we can run. And so every time a new version of requests comes out, or 9.1 for CircuitPython or 9.2 or 10 or whatnot, we can actually run the same test code across the same, different microcontrollers and actually figure out is SSL still working? Can I still connect to MQTT? Can I run a server? Can I do requests? And ideally with a goal of having a kind of similar to CSS has had this can I use? So you could go look and be I have this microcontroller, I'm using this radio, and I want to do this. Can I do that?
Well, that's great. It's been fun and exciting to watch you partner with the core devs as you've built this over the last few months. Thank you so much for being on the show.
Thank you very much. I really appreciate it.
And that's our show. A special thanks to Justin Myers. If you enjoy listening to the show, tell a friend or write a review. It really does help. For detailed show notes and transcripts, visit thebootloader.net. Until next time, stay positive.